Good morning, online SHS Honors Chem. Today we're going to start Unit 9, which is all about acid and base chemistry. And we're actually going to start with a little review on molarity. As you can kind of see on your screen, what we'll be getting into over the next couple of weeks. First, today, tomorrow, molarity and dilutions. And then later this week into next, we'll talk about acids and bases, kind of what they are, ways to define them, and these things called titrations. But today, really quick with molarity, going back to Unit 7, we should hopefully remember that our formula for molarity gets the capital M, and how we solve it is that it is moles of our solute. And remember, our solute is what we dissolve in solution, divided by our liters of solution. Now, we won't always specify it or say it in every single problem, but just note that if you see that word or volume of water, we're talking about solution there. Because again, acid and base chemistry happens in an aqueous or a water-based solution. So let's just try a couple of these real quick. So the first one asked if we have 4 moles of nitric acid molecules dissolved in 1.50 liters, what is our molarity? So that one's a little more straightforward. We know that our molarity is moles over liters. So to find or to answer that question, our molarity is just 4.00 moles divided by 1.50 liters. So we just put that into our calculator, and watching for significant figures, I think we should just get an answer of like 2.67 and 3 sig figs in that answer, because we have 3 sig figs here and here. And then remember, for our units of molarity, we can just use a capital M. It's not a nice looking capital M, but it's a capital M. And just really quickly here, I'm pressed for time. Let's do number 3 real quick. So number 3 asks, what is the molarity of a 0.5 liter solution containing 249 grams? Oh, grams, but we need moles. So just remember that if we have grams of our solute, we need to change that to moles. By doing our quick little conversion here, we have to use our molar mass of potassium iodide. So I want to go to my periodic table. And potassium's molar mass is 39.10. Iodine is 126.90. So when we add everything together, the molar mass is 166.00 grams. So 249 divided by 166, and that tells us we have 1.50 moles. So now to get our molarity is our moles of solute, 1.50 moles, divided by our volume of solution. So 1.50 divided by 0.50. And with 2 sig figs there from our volume, molarity would be 3.0 molar or capital M. So again, just a quick little review of molarity with this. Work for today is to finish the rest of these problems.